Alright. So, questions about last time? We're good? Alright, so we talk about comparisons. We talk about if statement briefly, and I show you what were the conditional operators, right? We did the equal, which you says double equals when you compare things, and remember there are two types of variables, and the two types were primitive, and if it's not a primitive, it's an object, right? And we said inside the primitives we have the int, booleans, the double, the characters, single characters, we got long, and in the object we have everything else. And you start using one last class, and the one we used was the scanner, right? And I'm gonna keep repeating this all the time until you memorize it. So, the operating system allocates 32 bits for this, 64, 64, 8, 64, oops, no, this is 1, oops, sorry. Right? And we said in this computer, since it's a 64-bit operating system, all the objects are 64 bits, right? And we said it's basically a pointer. Whenever you declare a variable that's not a primitive type, you're just holding an address, right? So allocates an address to hold just another address. And the address where it's pointing to is where the actual object is. We have that clear, right? Alright, so before you can use any variable, you have to declare them. We said that too. And when you declare a primitive type, let's say I say int, I think we use my age. I can do this. And it goes, and it saves it, right? But when we declare the object scanner and we call it keyboard, I couldn't do my age. It's called keyboards dot next int. We couldn't do that because we had to create this first in memory, right? And to do that, if you remember, we did something like this. New scanner, and we use, right? And then we could use it. And you remember the new keyword allocates memory. Then I told you there was an object that behaves as if it were a primitive type. Remember what type was that? It was a string. A string is just an array of characters. And I can do this. I can just assign it without having to do this new string, because the string is an object, but it behaves as a primitive type. That means you don't have to instantiate, we call that. Every time you see the keyboard new, we use the word instantiate, which means creating memory. We create an instance of scanner in here. So sorry, I'm coming out of a cold. However, string is still like an object. So although it behaves like a primitive type, it's still an object, right? So I think we did the example of, we did an if statement, right? That says if your age is greater than or equal than 65, you can say you can retire, right, or something, and then otherwise keep working, right? We did that last time, right? So this comparison, I'm comparing an integer, the contents of this variable, whatever is in memory, with the number 65. Now, let's say I'm not comparing that, I'm just comparing, let's say I'm turning 50, let's say. I wish I looked like this when I turn 50, but. So today, so if it's 50, I can do the two equal signs, right? And I say, happy half century, right? If not, then I can just say whatever. Doesn't matter, right? So, in memory, I'm gonna draw it here. So, we said this is address 1000, 1064, 1128, 1192, 1256. That's what I need. So when I declare variable my age, your brain system is going to say, oh, here's my age. And it replaces, every time it sees the value or the name of the variable, right, with the address. So here I assign the number 32. So the variable my age is an address 1000. So it's comparing the contents of address 1000 here, which is this, to the number 50. And it's gonna say it doesn't match, right? It's not the same. However, the last name it's a object. Right? And I said, oh, last name here is assigned to my last name. So actually the last name is somewhere else, right? And here the content of the variable called last name is just whatever it's pointing to, right? Wherever my last name is in memory. So the last name is replaced by 1064, right? Now, let me ask you something. Let's say I'm not comparing my age. I'm comparing my last name. If I say is that statement going to be true or false? What do you think? Why?
Because your name is not last name. Is that like?
Well, I put last name here.
All that's together?
Yeah, I just
One. Oh. One is equal to one is assigned to. As far as that. I'm just gonna guess.
second.
I said one is equal to, that's equal to, and I was just, you're assigning the last name to you.
So when I assign the last name, allocate memory, right, for my last name, because it's a string, and return the address where that was found, and puts it in this variable called last name, right? So if I say it's last name equal that, is that going to be true or false? Actually, it's false. That's you why. That's why I'm asking.
It looks like it's true, like the way you just explained it.
All right, so computer is going to turn this into binary, right? So what is the value of this? G, okay. So this one, the G is 71, value of 71, and I don't know. I think this is 105. I don't know, whatever. And at the end, it's gonna put another 000 at the end. It's called a no terminator to indicate that's the end of the string. So basically, whatever binary turns out to be of the last name, it's gonna give me a string of binary, right? Do you think that number is gonna be, what's the contents of last name? 1128, right? So you think my last name in binary equals to 1128? What if it's Washington, or the longer one? Still not 1128, right? So this is always going to be false. Because when you compare objects, what do you compare? What does this object have? An address, right? So every object, when you declare a variable type object, what do you store? The address. So when you're comparing objects, you are comparing addresses. The contents where that pointer is going to. So how do we fix that? So we said primitive types, we can assign them, and they don't have methods. Only objects have methods. Scanner is an object, and we have a method called nextInt, right? There's a method called nextString. There's a method called nextDouble, next whatever. So you type keyboard and you press the dot, and a list of all the methods show up, right? Primitive types don't have that. So the computer needs to know how to determine if two objects are the same, because as far as it knows or it cares, it's just comparing the addresses. But the objects, you can't compare addresses. You want to compare the contents of whatever those addresses are pointing to. So there's a method called equals. You press that, you have this method called equals. And now this will return true. So when you compare objects, you're gonna use the equals method. So what if instead of uppercase, I use lowercase? Will that be true or false? False, right? There's another method in the string called equals ignore case that you can use if you don't want it to be case sensitive. But if you use the regular equals, then it's going to be case sensitive. Any questions? Yeah.
What did you say when you were like, you were when comparing, you said when comparing like the two, before you change that to equals, you have double equals.
Okay, so when I use the double equals, I compare the contents of the variables, right? And objects only contain addresses. In other words, I'm comparing addresses. So if I want to compare objects, I cannot use double equals, because the only time they're going to be true if they hold the same address. I guess it will be true if I say I declare another string called first name, and if I do first name equal last name, then the first name gets the value 1192, let's say. So when I compare here, if I said whatever the value of last name, or last name is 1128, put it in first name, so both are pointing to the same thing, then they're pointing to the exact same name. There's no two separate names, last of this word in memory. They're pointing to the same. Any questions here? So, I suggest you don't miss class, because I'm going to give you a lot of material, and you're going to fall behind unless you're taking this class for the second time. But you don't want to do that, right? All right. Time is money, and if you're wasting time, I mean, you're delaying you becoming a millionaire by writing cool software. All right. Questions? We good? All right. So, erase this for now. And when I talk about classes, and what classes are, how they work. So classes in Java is another name for objects. So any object is a class. So there's a class built in. Well, there are many classes built in. There's one class called object. And every class we build, we say is an object. So what that means is, there's this class, we call it superclass. And it's built in, it's object, and it's the foundation of every class in Java. For instance, let's forget about Java and let's say we have a class called person. That's the foundation of all of us. A person. It has some certain attributes like you can think of, like hair color, eye color, height, weight, whatever. Name, address, stuff like that. That's the person. But then you create a student class that is actually a person. So we call this derived from the class person. So you can say, oh, every student I have is a person, right? But then, you can have another class called employee that's also derived from the person. So you say every employee is a person. Unless it's the police department, you have dogs, right? But that means every student is a person, every employee is a person. But then the superclass, person class, not every person is a student and not every person is an employee. Does that make sense? So this superclass in Java is going to be the object class. And to declare a class, you've already done one, right? And it starts like public class and then gives it a class name. Every class we make is going to be first word is going to be capital. First letter. And then we use the proper case. That means every first letter of the words are capital and the rest are lowercase. So somebody made this class called object. That looks like this. Can we create a class object? No. It's already made for us, right? So this is in Java. This is built in. And every object has some attributes. Alright? Like, let's say I want to make a class called car. Alright, let's do the class car. This is the car. Let's make a class called car. And I'm going to think of a list of attributes of that car. Well, the word attributes, we're going to change the name. We're going to use this instead. We're going to call it fields. They're the same thing. Okay? So when you go get your parking permit, what do they ask you? They ask you make, model, year, color, and license plate, right? So the year, what type do you think variable will be a year? What kind of variable would you use to hold a year? What? Yeah, an integer, right? Because you don't say, I have a 2015.5 year, right? So you don't hold, it's a number and it doesn't take decimals, right? So you say it's an integer. So we'll say I have a year. I'm gonna use, right? What about make, model, and license plate? What type of variable do you think you should use? String. So if I use a string, I can just say make a model license plate, right? And notice I didn't make a string for all three of them. First, because I don't want to write that much. And second, they're the same type, right? They're all strings. So I can declare them. If they're all the same, I just separate them by commas. And I can declare as many as I need, all in one line. What about color? What do you think it should be? Should it be a string or should it be a number? Have you ever played with like Photoshop or?
RGB.
Yeah, sure. You know what RGB means? RGB means red, green, and blue. Right?
So it should be.
And actually, there's a fourth one. I'll tell you what it is in a second. So basically, your eye, the counts of your eyes, have those three colors, and that's how you differentiate colors. And if you're colorblind, you're missing one of them, right? So we use a byte to represent each color. So how many bits is a byte? 8 bits, right? So 2 to the 8 is 256. That means I can represent 256 colors. And starting at 0, and 0 is a number, right? So I have to count 0 as one number. So the values are from 0 to 255, right? For each one of them. Right? So if I have 3 bytes here, right? So I have 3 times 8, right? Bits. I have 24 bit, right? So that's what's called a 24-bit color. When the computers first started, they were black and white. And then they started with 16-bit colors. And now with 24-bit, you can represent 2 to the 24 numbers, right? They just broken down into the first, the rightmost 8 bits is the red, the second set of 8 bits is the green, and the last set of bits is blue. So before the current Windows we have, I mean even Windows 7 have 2 flavors, 32-bit and 64-bit. So 32-bit was the prominent word size for the longest time. But the computer cannot allocate 24 bits, right? It allocates 32 bits or 64 bits. Right? So, what do we do with the other 8 bits? Do we waste them? No. We put an A in front of it. And this also gives the values 0 to 255. And you know what A is? You know what A is in phonetic alphabet? Alpha, right? So this is the alpha color. So what is the alpha? This is used for transparency. So basically it's the level of transparency. Like when you have a window, you can see kind of like what's behind. That's what it is for. So we're going to have a 32-bit number now, right? What kind of variable will be a 32-bit number? An integer, right? So guess what? I can represent the color with a 32-bit number. Questions? All right. I'm gonna, let's take 10 minutes because what I'm gonna explain next is gonna take me 40 minutes. Okay.